In 4.2, we're going to be looking more at these logarithmic functions. We're going to pick up some properties. So the first thing we want to look at is something called the one-to-one property. And it says, looking at our exponentials that we've been working with in the previous section, if we have the same basis and they are equal, then we can set those exponents equal to each other and work it out and solve for x, right? The main goal of solving most of our math problems. So what we're going to have to do is we're going to have to manipulate some in order to achieve this same basis. So as always, have your scientific calculator ready to go to kind of help you through this and to figure out what we're working with. So I'm going to have this over to the side. So when I'm looking at a problem like this, if I want to get it in this one-to-one property form, I want to take the larger number and create it into the smaller number. So I'm going to come over here to my calculator. I'm going to say 3. Remember, this button right here raises it to an exponent. So I'm going to raise to the first. Well, that's just 3. Raise it to the second. That's 9. Raise it to the third. That gives me 27. They get big pretty quick, so getting to 27, you can see, didn't take very long. So instead of 27, I'm going to write 3 cubed. Now that I have the basis to be the same, I can set these exponents equal, and I can say x plus 1 is equal to 3, and then I can solve out from there. So x is equal to 2. And so this one-to-one property is really nice, but sometimes you might need to manipulate it in order to get that property to fix. Let's look at this one, 1/2. So what I want to do first is I want to bring back some Algebra 1, some properties of exponents. This is like 2 to the first. If I take this 2 to the first and bring it up here to the top, that's like 2 to the negative 1. Raised to the x is equal to 8. And by rules of exponents, I can multiply those two together and I get 2 to the x, negative x, equal to 8. So this is already more user-friendly than that 1/2. Now I need to do the same thing with 8, but I need to change it into a power of 2. So I'm going to come over here again, say 2 squared, well that's 4. 2 cubed, that's 8. So instead of writing 8, I'm going to write 2 cubed. So now I can those exponents say, well, that means negative x has to be equal to 3, and then do a simple solving for x to give me negative 3. So again, you can see this one-to-one property is at work, but you got to just be able to work, use your algebra skills, manipulate to kind of get it into that form. The next one is the basis that we looked at in the previous section. If they're both the same basis, we can just set our exponents equal. So I say x squared plus 12 is equal to 7x. And hopefully from Unit 1, anytime you see a quadratic, you think, get them all over to the one side, set equal to 0, and solve. So let's see if this one will factor. I'll draw my two parentheses equals. So what will multiply to give me x squared? Oh, sorry, that was a 7. Is x and x. And then I think what will multiply to give me 12? Signs are going to be the same, both negative. Multiply to give me 12 and add to give me 7, and that's a 3 and 4. And then I just solve it out from there. So we can't forget all of our factoring skills that we've picked up along the way, because you can see this step right here comes from 4.2. This whole process comes from Unit 1. So the one-to-one property is really nice because it's going to help us with working with these. So let's dive a little bit deeper into our logarithms, and then we'll kind of come back into that one-to-one property. It says Introduction to Logarithmic Functions. The logarithmic base b function is written as log base b of x is the inverse of the exponential function of base b of b to the x. And so we're going to use this interchanging of the logs and the exponentials, and that's why they're all in the same unit to help us figure it out. You'll notice that if I want it to go from a logarithm and rewrite it as an exponential, the base of the log is the base of our exponent. A logarithm is equal to an exponent, so you can see what it's equal to is the exponent on my exponential. And then c is the last letter. Now this explains how things are similar, but I have another method that'll help us with this. What I do is I call it the snail method. And what it says is if you start right here with the b, and I kind of make a snail shell here and come around, that this would give me the order in which I would need to fill in to convert into this manner. So going from a log to an exponential, I know it would need to be in this form. So I start here, so B starts, I circled to A, I landed at C, and that gives me my exponential. That same method works with an exponent. Say I want to take an exponential to a log, I'll snail it around, So I'm doing log base something equal to something. So B goes in the first spot. I went to C next, and then A went to the next spot, which you can see is what we started with here. So let's practice with this, because at the base of it on your exam and on your homework, you're going to have to be able to go from a log to an exponential and an exponential back to a log. So in this first one, let's write logarithmic equations as exponential equations. So I have my log equal to a number, and I'm wanting to rewrite it as an exponential. So I know it's going to take this form here. And so I'm going to use that snail method to kind of help me with that. Start at the 2 and circle around. This tells me the order in which I want to fill them in. So it's going to be 2 to the third power is equal to 8. And that's it. They just want me to rewrite it as an exponential. I'm not trying to solve it. I'm not trying to figure it out. We will eventually use it to solve, but this will help us in order to figure out how to rewrite it. So we're just practicing rewriting. So I'm going to do it again. I'm going to start here, loop around. So that would mean it would be 5 to the second power is equal to 25. And the good news is when I'm working with numbers, I can see if it kind of makes logical sense. And 5 squared is 25. So all I'm doing is rewriting. Same thing here. 6, I'm going to move to the 1/2, and then I'm going to move to the square root. So I want to make sure I keep those groupings. So it would be 6 to the 1/2 is equal to the square root of 6. And again, that makes sense. Now we're going to do some that have variables in them that may not make as much sense. But if we can get it in these that make logical sense when we get done, that helps to reassure we have our process. Now I want to go from an exponential to a log. So again, here's going to be kind of my template. Here's the log. And so I'm going to use that same method to figure out the order of filling in my boxes. So I start here and I snail it around. So it goes 2 and then 32 and then 5. Let's do it again over here, but I'm not going to draw the template this time. So I start here and I loop it around. This gives me log base 10 of 1 over 1,000, keep that whole grouping together, is equal to -4. Now typically we don't write base 10, so we could just write log of 1,000 equal to -4. So again, this paper was just showing us how we could go from logs to exponentials, and in the future you're going to see how this kind of works out for us. So let's work this example here. Evaluating logarithms. So the first thing I want to do is I want to evaluate at 32. That gives me log base 2 of 32 equal to, and I like to put my y over here so that method works for me. Now it told me to evaluate this, and I can't evaluate that. I don't know anything else, but I know how to change from a log to an exponential. So I'm going to rewrite it as an exponential. 2 to the y is equal to 32. Then I'm back to the 1-to-1 property. 2 to the y is equal to, I'm going to grab my calculator, come over here. And so let's see, 2 to the 4th is 16. 2 to the 5th is 32. So I'll say, well, that's equal to 2 to the 5th. So now by the 1-to-1 property, y is equal to 5. So two things we did here. One, we went from a log to an exponential. And then two, we used that 1-to-1 property in order to solve. So you're going to see lots of stacking of properties as we go. Let's do the same thing here. So I'm going to plug in 2 for x. So this gives me log base 4 of 2 equal to y. I'm going to snail it around to rewrite it, so it gives me 4 to the y equal to 2. Now I always try to turn my larger base into my smaller base. So I come over here and I say, okay, 2 to the second power, that's 4. So instead of 4, I'm going to write 2 squared. To the y equal to 2. Power to power you multiply, so that's 2 to the 2y is equal to 2 to the first power, because if there's non-power, there's a 1 there. Then by the 1-to-1 property, 2y is equal to 1, and then solve from there. So I get y to be 1/2. So you can see following my steps helped me to figure out that y was 1/2, whereas a logical approach I may not have gotten there. Now speaking of calculators, there's 2 different types of logs that we can type in our calculators at this point. We can do the common log that's base 10, which we could write a base 10 there, but a lot of times it's written without. And there's the natural log that has base e, which again, we typically don't write log base e, we write ln x. So these are the 2 forms that you're able to work with your calculator without any additional processes. So I want you to grab your scientific calculator and work through this with me and make sure you're getting the values as you go. It's important to get the values here when we're working together so that when you go on your own, you're sure that your calculator is doing the right work and you haven't made a mistake with it. And so I'm going to grab my calculator here. So the 2 buttons I'm going to use is my log button and my ln button. Again, you can only use a scientific calculator on your exam. So if you're still leaning on that graphing calculator, you're going to be out of luck on that test. I want to evaluate ln 500 to 3 decimal places. So I'm going to hit ln of 500. I'm going to close the parentheses. And that gives me 6.2146. Now remember rounding. If I want to round to 3 decimal places, I look at my fourth. If it's 5 or larger, I round up. So my final answer would be 6.215. Again, take a minute, pause, see if you can get that with your calculator to make sure you're able to use your calculator proficiently. Next, I want to use my log button. So I'm going to hit log of 3. I'm going to close my parentheses. And this gives me 0.477, which you can see we wouldn't have to round. So just a little quick practice on how to work with your calculator and evaluate that, and that'll be beneficial as we move forward. Now let's really get into some coolness and some cool things you can do with logarithms, such as some of their properties. These properties are really nice. Things that we need to know: if we have log base b of 1, that is always 0. It doesn't matter the base of b. I love that as a test question to give a problem like log base 314 of 1. And what does that equal? 0. There's no work to be had. It's just knowing log of any base. If it's 1, log of 1, it's always 0. The same is going to be true for our natural logs. So going forward, I'm going to do natural logs along the side here. So ln of any base, even base e, again, is just 0. This one we could check in the calculator. This one we cannot. But nice property and really quick, easy problem for me to put on a test. The next one says, if I'm doing log of base b of b, having the base the same as what I'm logging actually just gives me 1. So ln, this is like a base e assumed here, ene just gives me 1. I remember this one a lot easier because it almost looks like line, like I could put a line through it, which just gives me 1. Knowing this property helps us with our inverse property. And it says log base b of b to the x. Again, notice the base of your log and what I'm logging are the same. They essentially cancel each other and just give you an x. The same is true here, and I like my line trick with this one. This looks like almost line, like I could put a line through it and just outputs x. We're going to use this property going forward, and it's really nice for us. This is still the inverse property, but it's just switched up how they're written. So the base of my exponent is the same as the base of my log, so it's just going to give me x. And then e to the ln. My lne kind of looking like line makes sense here. Here it's just when your e's and ln's are beside each other, they essentially cancel because they're inverse functions of each other, such as like multiplying and dividing being inverses, adding and subtracting being inverses. So let's see what we can do. Now our last property we can do up here goes back to the beginning of this section, and it works with the one-to-one property. So with exponentials you have the one-to-one property, so do you have with your logarithms. So if we're taking the log of the same base of x, log of the same base of y, then we can just go ahead and say x is going to be equal to y. All that may sound really confusing, all those letters. So let's do some examples with properties. Again, love this test problem. Log base, who cares the base, log of 1, always 0. You can see no work to be had. ln of 1, always 0. These are going to go really quick. Log, if your base and what you're logging are the same, that's just 1. lne looks like line, like I could put a line through it, so 1. Here's our inverse property. Your base and what you're logging are the same, so this all would cancel to just give me 5. lne cancels to give me 15. Over here, base 6 and log 6, again, inverse properties cancel to give me 20. And ln cancels to give me 7. You can see all those properties, any of those given problems on a test, there's really no work to be had. There's no calculator to be used. It's just knowing your properties, and this is going to help us in moving forward in the next sections. Now let's put together some of the one-to-one properties. So this says if my logs are the same, whatever I'm logging should be equal, so that means x is equal to 12. It looked confusing, but by my one-to-one property, I just had one step. The same is true with your ln's. X is equal to 4. I'm ln'ing both sides. They're equal. That's all I got. So x has to be 4. Basic problems. Let's step it up. Log and log. So I'm logging both sides. They're equal. So that means 2x plus 1 has to be equal to 3x. And then I just solve for x. So that gives me 1 equal to 1x. Over here with LNs, if I'm ln in both sides, then that means by the one-to-one property, x plus 3 has to be equal to 7, and then I can solve it from there. So x is 4. A little bit harder, last problem. I have log base 4 equal to a log base 4, so I'm just going to set what I have equal x squared minus 6 equal to 10. I'm going to add 6. Now I'm back to solving a quadratic again. So I'm going to square root. Now remember, when you square root a variable like that, you have to compensate for the positive and negative it could have been. Square root of 16 is 4. So again, this comes from Unit 1. Make sure you remember how to solve your quadratics. But that first little step is just applying our one-to-one property. So I hope this helps with 4.2. If you have any questions along the way, feel free to holler at me and let me know. Just shoot me a Canvas message, say, hey, I had a question about logarithmic functions in the homework number 8, and I'll help you with that.